So in our first example, we're going to look at a situation where we're given a demand function. The demand function is Q is equal to 40 minus 1/5 of P, where of course Q is quantity in demand and P is price per item. And our situation is that we have an item that is currently priced at $120, and we're going to increase the price to $150, or at least consider a price increase to $150, and see what elasticity value results. So remember that what we have to do is look at the percent change for the price and the percent change in the quantity and demand. So that means that we're going to need at least two values of each of price and quantity. And of course we have two prices here, and since we're given a demand function right up here at the top, if we have the prices we can then get the corresponding quantities in demand. So if we start with a price of $120, we can find the quantity in demand at that price by substituting P equals 120 into the demand equation that you see given at the top of this slide. So if we substitute 120 for P, we get this. So Q is equal to 40 minus 1/5 of 120, and that leads to 40 minus 24. 1/5 of 120 is 24, and of course 40 minus 24 is 16. So the quantity in demand, the number of items that we expect to sell at that price, is 16. And we're going to as a point on the graph, on the demand graph. So our first coordinate is P, our second coordinate is Q, and we're taking that from the equation. Q is a function of, or depends on, P, so we're thinking here of P as the independent variable. So we have a point, 120, 16. We can also do the same thing for the price of $150 per item. We substitute that into the demand function. So 40 minus 1/5 of 150 is 40 minus 30, or 10. So at a price of $150 each, we expect to sell 10 of those items at that price. Again, that gives us a point on the demand curve, 130, 10. So there we have it, our 2 points, our two values of Q and our two values of P. And as long as we have those, we can do some percent calculations. So let's do that on the next slide. So let's go ahead and continue with this example. Keep in mind we've just generated 2 points. We're starting with a price of $120 and increasing to $150, and that results in a decrease in quantity and demand from 16 items down to 10 items. So we think of these as 2 points, P, Q. Now remember, our elasticity equation asks us to look at the percent change in quantity and demand. So here's the calculation for that. The percent change for any item can be found by looking at the new value, so our new quantity and demand is 10 items, minus the original, which is 16. So new minus original is 10 minus 16, and then you divide by the original value of 16 in order to get the percent change. So in this case, we have -6 divided by 16, or -0.375. So here, this corresponds to a 37.5% decrease in quantity and demand. And it's negative, of course, because the demand is decreasing. So that is half of the elasticity equation. The other half is the percent change in the price. So we do that calculation in a similar way. The new price is $150 minus the original price is $120 divided by the original price of $120. So that's 30 over 120, or 0.25. So this corresponds to a 25% increase in the price. So notice the decrease in demand, 37.5%, is greater than the corresponding increase in the price. So therefore, when we take the ratio of those two percentages, we end up with 1.5. The numerator is larger than the denominator, therefore our ratio is bigger than 1.5. And you notice here we take the absolute value of this ratio to end up with just a positive elasticity value. So our elasticity value here is 1.5. This means that because it's bigger than 1, we have an elastic situation and our revenue decreases because our quantity and demand is dropping much more quickly than our price increase. One important thing to notice about the last example is the fact that we've swapped the variables and the positions that they normally take. In the last example, our independent variable changed from Q, as it was in previous topics, to P. So now we're thinking about the price being on the horizontal axis. And instead of looking at P as a function of Q, or P is equal to D of Q, as in topics 1, 2, 3, 4, and 5, we now have Q is a function of P, or quantity and demand is a function of price. Both of these are demand functions because they both give me a relationship between the price per item and the quantity and demand at that price. So they're really the same thing, they just have swapped the variables. So let's take a look at a quick visual picture of what's going on here. So as we look at the pictures, what we want to do is keep in mind that we are allowing the price to increase in these examples. So we can think of price as the independent variable. That's the thing that's allowed to change. And as a result of a price increase, we see a corresponding decrease in demand. So in this situation, it makes more sense to put price on the X, or the horizontal axis, as opposed to the vertical axis, which is what we've been doing up until now. So some people actually are used to having price on that horizontal, so this is going to seem more natural to them. Other people are used to seeing price on the vertical, so this is going to be a shift for them into something that's new. But if we look at what we saw before, we see P is a function of Q, or P is equal to D of Q. Q was on the horizontal, P was on the vertical. And now we're doing something different. Instead of Q being here on the horizontal and P on the vertical, we're now making a shift to the opposite. So here we have Q is equal to D of P, or Q is a function of price. As price changes, quantity changes. So we have the price on the horizontal axis, and then what depends on that is the quantity and demand.